Welcome to CodeViral. Today we're going to talk about a foundational pillar of modern life, the internet, and more specifically, the companies that control it. Think about this. In the United States itself, a third of the population has absolutely no choice in who provides their internet. Globally, the ISP market is valued at over $1.2 trillion, and it's controlled by just a handful of massive corporations. This centralization has created a system of digital landlords. But what if there was a way to build a different kind of internet, one that is owned by the very communities it serves? It might sound like a fantasy, but it's not. It's a reality being built right now, all powered by a single, elegant protocol that could fundamentally change everything. Let's explore how. Before we get to the solution, we have to clearly define the problem. The way our internet is currently structured, while functional, has some deep inherent flaws. First, there's monopolistic control. The immense cost of laying fiber optic cable has created these natural monopolies. A few giants control the infrastructure, and therefore they control our access. This leads directly to the second problem, high prices. With little to no competition, these companies can charge more for slower speeds, leaving most of us with no real alternatives. Third, there's the risk of censorship. When all of our data flows through central checkpoints, it becomes trivial for a corporation or a government to filter, block, or monitor information. And finally, single points of failure. We've all been there. Your ISP has an outage, and your connection to the digital world is just severed. The whole system is fragile because it's centralized. Let's look at the data. This isn't just theory. This is the reality for millions. On the left, you see the state of broadband competition in the US. A staggering 66% of Americans have, at most, 2 providers to choose from. This isn't a healthy, competitive market. It functions more like a cartel, where the dominant players have very little incentive to innovate or lower prices. On the right, we see the market share. 4 companies, the Big Four, dominate the entire landscape. This is the kind of concentration that allows all the problems we just talked about to exist. So, what's the alternative? To understand it, we need to visualize the structure of the network itself. Here we see 2 completely different worlds. On the left is the traditional ISP architecture. It's a hierarchy. Data flows from a central core down to regional hubs and finally to you. Notice the choke points. If that ISP core fails, the entire network connected to it simply goes dark. It is inherently vulnerable. And on the right, we have a different model, a peer-to-peer mesh. It is decentralized and distributed. There is no center. Every point connects to multiple other points. Data can flow along countless paths. It's resilient, and by its very design, it's free from that central point of control. Let's break down this idea of a mesh network. The concept is remarkably simple yet profound. In a mesh network, every device, your router, your phone, your laptop, can become part of the network infrastructure itself. It acts as a node capable of routing traffic for other devices around it. This means you don't need a central authority to manage everything. The network is self-organizing, and most importantly, it's self-healing. If one node goes offline, traffic just finds a new path, flowing around the failure like water around a stone. The network is literally owned and operated by the community that uses it. But for a system like this to work at scale, it needs an intelligent way to manage all those connections. It needs a brain. And that brings us to the hero of our story, B.A.T.M.A.N. It stands for Better Approach to Mobile Ad Hoc Networking. It's a routing protocol designed specifically for these kinds of decentralized, multi-hot networks. At its core, it creates a form of collective intelligence. Instead of one central router needing to know the entire map of the network, each node only needs to know the best direction to send a piece of data. It's an elegant approach that eliminates single points of failure and allows the network to organize itself on the fly. So how does it actually work? The process is remarkably simple. Step 1. Every node on the network periodically broadcasts a tiny "I am here" message to its immediate neighbors. Step 2, when a node receives one of these messages, it simply passes it along to its own neighbors. This way, information about every node gently ripples throughout the entire network. Step 3, as these messages spread, each node listens and learns which neighbor provides the best path to reach every other node it hears about. It builds a simple, efficient routing table. The result in Step 4 is that collective intelligence. The magic here is that no single node has to carry the burden of knowing the full complex map. It only has to know the next best step. The network routes itself. Now, B.A.T.M.A.N isn't some new, unproven idea. It has been in development for well over a decade, constantly getting smarter and more efficient. As you can see on this timeline, early versions were simple. They just counted the number of hops to find the shortest path. But the developers quickly realized the shortest path isn't always the fastest. Later versions began measuring the actual quality of the wireless link, avoiding connections that were slow or unreliable. The most recent versions are incredibly sophisticated, operating at a deep level of the network for maximum efficiency and speed. This protocol learns and it adapts. Now, it's important to be realistic. This is not a magic bullet. Mesh networks face a very real physical limitation. It's called the hop penalty. As this chart shows, every time your data makes a wireless jump from one node to another, the maximum speed is effectively cut in half. At the same time, the delay, or latency, steadily increases with each hop. After just 4 or 5 hops, performance can degrade to a point where streaming video or making a voice call becomes impossible. Physics is still physics, so how can this ever compete with a fiber optic cable? Well, it's already happening. Despite the limitations, community networks powered by B.A.T.M.A.N and similar protocols are thriving all over the world. The most famous example is Wi-Fi.net in Spain. It's one of the largest mesh networks in the world, with over 37,000 active nodes, providing an internet lifeline to rural communities that traditional ISPs simply ignored. Here in the States, NYC Mesh is bringing affordable, high-speed internet to residents across New York City, bridging the digital divide. And in disaster zones where normal infrastructure has been destroyed, these networks can be deployed in a matter of hours to provide life-saving communications. These projects prove the model is viable. I'm genuinely curious, have you ever heard of or used a community network in your area? Let me know down in the comments. I'd be interested to see how widespread this movement really is. This all leads to a very practical question. How do you pay for a network that is supposedly free? There are several models, each one with its own trade-offs. Grant-based projects are easy to start, but often struggle to survive long-term. Purely volunteer-run networks have incredible community spirit, but can have trouble scaling or offering truly reliable service. The most successful model, the one used by projects like NYC Mesh, appears to be the self-sustainable cooperative. Members pay a small, affordable monthly fee. This creates a consistent revenue stream that pays for professional maintenance, hardware upgrades, and the high-speed connection to the global internet. It's what ensures long-term success. Of course, the path forward isn't without its own major hurdles. We've already talked about the performance limits, but there are others. Then there's security. In a network where every node is a router, you have a much larger surface area for potential attacks. There are also scalability issues. As a network gets bigger, the background chatter to manage routes can start to slow things down. And finally, there's questions of governance. In a decentralized system, who gets to make the big decisions? These are difficult problems that are still being actively solved. This brings us to what's likely the most realistic vision for the future. It's not about replacing the entire internet with wireless mesh. It's about a hybrid approach. The solution is to combine the strengths of both worlds. We use local, community-owned mesh networks to solve the last-mile problem, that final expensive connection from the street to your home. This is what breaks the local monopoly. These local meshes then connect to a shared high-speed fiber backbone, which gives them global connectivity. You get the best of both worlds, local control and community ownership combined with world-class performance. This is how you break the ISP monopoly without having to sacrifice speed. If you appreciate these kinds of nuanced breakdowns of complex technology, we publish videos like this regularly. A subscription to the channel ensures you won't miss them. The beautiful thing about this movement is that it's fundamentally grassroots. This kind of revolution doesn't come from a big corporation. It starts with individuals. You can start small by learning and experimenting. Set up a little B.A.T.M.A.N network with a couple of cheap computers. You can join online communities and find local mesh networking groups in your area. If you're a developer, you can contribute code directly to these open source projects. And finally, you can support policies that protect the rights of communities to build and operate their own networks. So to answer the question from the very beginning, will B.A.T.M.A.N kill ISPs? Not exactly, but it has the power to transform them.
It forces them to evolve. They can no longer be monopolistic gatekeepers, controlling our access and filtering content. Instead, they have to shift their business model. They become wholesale backbone providers, the companies that sell high-speed data to the community cooperatives. They would become infrastructure partners, forced to compete on the quality and price of their service, not on a captive monopoly. The internet was always meant to be a decentralized network of networks. Protocols like B.A.T.M.A.N are, in a very real sense, bringing it back to its roots, bringing it home. Thank you for joining me on this analysis. If you're interested in exploring other technologies that empower individuals, I have a curated playlist of what I consider to be the best free AI tools available right now. You can find a link to that on your screen. Until next time, this is CodeViral.